previous class, we have done the revision of determinant and matrices. And I hope you must have tried some previous year more questions on your own. So today we will start with the revision of sequence progression and binomial theorem as much as we can. All right. So first of all, I'll start with arithmetic progression. So in arithmetic progression, I'll start writing with the important formula. A plus D, A plus 2D, A plus 3D. This is a standard AP you all are aware of. Its nth term is A plus n minus 1 into D. This is the sum of n terms for an arithmetic progression. And this is the nth term for the arithmetic progression. And formula for sum is n by 2, 2A plus n minus 1 into D. All right. So there you have formula for the nth term and formula for sum up to sum of n terms. This formula is also remembered as n by 2 A plus Tn. That is n by 2 times first and last term. Okay. One more thing to remember. Sum of n terms. Sum of n terms of an AP is a quadratic in n without any absolute term. Means if you find some series given as an square plus bn, now they ask you, is it the sum of n terms of an AP? Yes, it can be. But if they say a series is like an square plus bn plus c, is it the sum of n terms of an AP? Can it be? Then the answer is no, this cannot be. Here also you realize this is a quadratic in n without any absolute term. There is a term of n square, there is a term of n, but there is no constant term. Am I clear? So this is the formula for sum of n terms of an AP, nth term of an AP, and how a quadratic can be the sum of AP. Now, a few more things I'll mention. Sigma n. Sigma n. That is 1 plus 2 plus 3 up to n. This is what? Sum of first n natural numbers. And the formula for this is n into n plus 1 upon 2. Correct? Then sigma n square. That is 1 square plus 2 square plus 3 square up to n square. This is n plus 1, 2n plus 1 upon 6. Then there comes sigma n cube. That is 1 cube plus 2 cube plus 3 cube up to n cube. This is n into n plus 1 upon 2 whole square. Correct? Madhukar, understood? Now there comes the sum of first n even natural numbers. Even natural numbers. That is 2 plus 4 plus 6 plus 8 up to 2n. And this is equals to n into n plus 1. And then sum of first n odd natural numbers, that is 1 plus 3 plus 5 up to 2n minus 1. And formula for this is n square. I hope you will be able to remember all these formulas. Now you have sum of n terms of an AP, nth term of an AP, sum of first n natural numbers, sum of the squares of first n natural numbers, sum of the cubes of first n natural numbers, sum of the first n even natural numbers, and sum of the first n odd natural numbers. One more thing that we can remember to be very quick. 1 plus 2 plus 3 plus 4 up to 100. The sum is 5050. Got it? Now try this question. This is all about AP. Now another things are like say first and last term sum is same, second and second last sum is always same. Like terms equidistant from the beginning and from the end have same sum. Terms equidistant from the beginning and from the end have same sum. All right. Now go with this question. Let 3, 7, 11, 15 up to 403 and 2, 5, 8, 11 up to 404 be two arithmetic progression. Find the sum of the common terms in them. Yes, be quick. Yes, yes, quickly. See, there are two series. One is 3, 7, 11, 15 up to 403. Am I correct? Another is 2, 5, 8, 11, and so on up to 404. There you see the common difference is 4. And there you see the common difference is 3. Now 4 and 3 are co-prime to each other. That means the series with their common terms that will have a common difference of LCM of 3 and 4. Series with their common terms with their common terms will have LCM as 12. That is LCM of 3 and 4. Now, first of all, we'll identify the first common term. So the first common term that you see is 11. 11 is first common term. That means series with the common term will be 11. Next will be after 12, that is 23. Then 35 and so on. This is how it is going. Series with the common terms will be like 11. See here next term what you see 15, then 19, then 23. So next will be 11, then 23, then 35 and so on and so forth. Now I need to identify what is the last term and then we will be able to get the common terms. All right. Now if you realize, let us assume any term is Tn. Tn is 11 plus n minus 1 into 12. And definitely it has to be less than 403. Why? Because the maximum we can have a common term as 403. So that means n minus 1 into 12 is less than 403 minus 11 will be 394. So n minus 1 is less than or equals to 394 upon 12. So n minus 1 is less than 3. N minus 1 is less than 36, 34, 32 point something. So n is less than 33 point something. So if n is less than 33 point something, means number of common terms are going to be 33. Got it? Now the number of common terms are 33. So series is like 11, 23, 35 and so on up to 33rd term. Now this sum is going to be sum of 33 terms, or sum of common terms is 33 by 2, 2a, that is 22, plus n minus 1, 32 into 12. So it is 33 into, this will come out as 11 plus 32 into 6. And if you simplify it, answer you will get as 6699. This question was there in JEE Mains this year only, 2024. Am I clear, Madhukar? Now let us start with geometric progression. See, we cannot, this is a one shot class, we cannot do everything. But still I'm trying to do like we have done a PYQ, which is a very good question. And also I reminded you all the formulas. Now geometric progression, the standard appearance is AR, AR square, AR cube and so on. So in this case, nth term is AR to the power n minus 1. Nth term is AR to the power n minus 1. And sum up to n terms is A r to the power n minus 1 upon r minus 1. So first of all, these are the two important formulas that you have to remember. A r to the power n minus 1, sum is A r to the power n minus 1 upon r minus 1. Got it? Now if it is an infinite GP, if it is an infinite GP, so in that case, infinite GP, first of all, common ratio should be between minus 1 to 1. Only then we can find the sum of an infinite GP. So if r is minus 1 to 1, only then sum of infinite terms can be evaluated. Got it? So if r is lying in minus 1 to 1, only then sum of infinite terms can be evaluated. And in that case, sum of infinite terms formula is a upon 1 minus r. Sum of infinite terms is a upon 1 minus r. Got it? Now, if you multiply a GP, if we multiply a GP by a non-zero constant, if we multiply or divide a GP by a non-zero constant, it still remains a GP. It still remains a GP. But yes, if you add or subtract something from a GP, it will not be a GP anymore. Got it? So these are the two main important formulas regarding GP. If we have to consider three terms in GP, consider three terms in GP, consider them like A by R, A, AR. If you have to consider four terms in GP, that should be A by R cube, A by R, AR and AR cube. And if I have to consider five terms in GP, that should be A by R square, A by R, A, AR, AR square. Alright, A by R square, A by R, A, AR, AR square. The prime purpose behind this kind of assumption is, if in a question they are asking like three terms or four terms are in GP and they are talking about their product or their product is given, only then it is worth considering these terms. So that you directly multiply and you get the value of A. If they are not talking about the product of these four terms in GP, then there is no point of assuming terms like this. They will only increase your level of difficulty. So in that case, I have to sometimes assume three terms in GP. So I can directly assume AR square if they are not talking about the product of the terms in that particular question. Understood? Well, now try this very simple question. 3 A, B, C are in AP, 3 A minus 1, B plus 1, C plus 9, B in GP. Then the arithmetic mean of A, B, C is. Arithmetic mean of ABC means they are talking about A plus B plus C upon 3. What is this? Tell me. Quickly give it a try. Yes. I give you a minute to think. And whenever you get the correct answer, mark your answer in the poll section. Yes, please. Three ABC are in AP, 3 A minus 1, B plus 1, C plus 9 are in GP. This question is also from like 2023 JEE means. Anybody quickly? Yes, yes, please, please, please. See, now let me try. They are saying 3 A, B, C. They are in AP. Let us assume this term is 3. This is 3 plus D. This is 3 plus 2D. And this is 3 plus 3. Got it? Now, 3, A minus 1, B plus 1, C plus 9. They are in GP. That means 3, A minus 1 will be 2 plus D. B plus 1 will be 4 plus 2D. And C plus 9. C plus 9 will be 12 plus 3D. So they are saying they are in GP. In GP means 2 plus D upon 3 is 4 plus 2D upon 2 plus D. That should also be equals to 12 plus 3D upon 4 plus 2D. Got it? Now, if I consider these two altogether, so 2 plus D upon 3 comes out to be 2 because 2 common, 2 plus D cancel. So 2 plus D is 6 implies D is what? 4. Now, one more option let me take. If I take these two, so 2 equals to, take 3 common. So it is 4 plus, 1 minute, C plus 9. So 4 plus, price of 4 plus D upon 4 plus 2D. Now if I cross multiply into it, so it is 8 plus 4D is 12 plus 3D. So there also I'm getting D as 4. So if you get D as 4, that means your terms A is 4 and 3, 7. B is 8 and 3, 11. And this is 15. So arithmetic mean of all of them is 7 plus 11 plus 15 by 3. So that is 15, 26 and 7. 26 and 7 is 26 and 7 is 33. 33 by 3 is 11 is the correct answer. Understood? Now, attempt this question. In a GP of 64 terms, the sum of all the terms is 7 times the sum of odd terms in the GP. Then the common ratio of the GP is equal to. Now see, sum of odd term means sum of the terms occurring at the odd places. Means first, third, fifth, and so on. Yes, quickly. If you get the correct answer, mark your answer in the poll. Yes, be quick. In AGP, sum of all the terms is 7 times the sum of odd terms of the GP. And what I'm telling you, sum of odd terms means sum of the terms occurring at the odd places. Then common ratio of the GP is equal to. Madhukar, anything? All right, nobody. Now, in a GP of 64 terms, the sum of all the terms means A plus AR plus AR square and so on, all 64 terms is equal to 7 times sum of the terms occurring at the odd places. That means A plus AR square plus AR to the power 4. So, so this will be equals to A plus AR square plus AR to the power 4. Now there will be 32 terms. Because the total terms are 64, so they are going to be 32 terms. So this is A r to the power 64 minus 1 upon r minus 1 is 7 times A r square to the power 32 minus 1 upon r square minus 1. Am I clear? Now r to the power 64 minus 1 cancel, A cancel. So it is r minus 1 into r plus 1 is 7 times r minus 1. R minus 1, r minus 1 cancel. So your r is 6. This is your correct answer. Common ratio of the GP is 6. Am I clear? Common ratio of the GP is 6. Got it? Now harmonic progression. See, this harmonic progression is no different thing. We are not going to remember any formula for this. Even there is no formula. Simply one thing you have to do. If A, B, C, D, E, say these terms are in harmonic progression, that means 1 by A, 1 by B, 1 by C, 1 by D, and 1 by E, they are in arithmetic progression. Now we will solve everything accordingly like they are in AP. Fair enough? So it has nothing to do with harmonic progression, nothing new. We will deal everything like they are in arithmetic progression. Now there comes AGP. Equation we'll do in a while. AGP, first of all, a series which is having an AP and a GP moving simultaneously. Like a series is S equals to A plus D into R plus A plus 2D into R square plus A plus N minus 1 into D into R to the power N minus 1. This is the n terms of an AGP. Now if you realize an AP is going A plus D, A plus 2D, A plus N minus 1D. And simultaneously a GP is going 1, R, R square, R to the power N minus 1. So this is what? This is an AGP. Now this is the same series as you multiply this series by R. And write again by pushing one term. So AR, A plus D into R square. Here it will be A plus N minus 2D into R to the power N minus 1 and A plus N minus 1 into D into R to the power N. Now we subtract both of these series. So this is S into 1 minus R. This is equals to, here it is A. This will come as dr. This difference will be dr square. This will be dr to the power n minus 1 and this will be minus of a plus n minus 1 into d into r to the power n. Now just keep this a aside. Just keep this a plus n minus 1 into d into r to the power n aside. In between this, if you realize, this is what? This is a GP of n minus 1 terms. This is a GP of n minus 1 terms. So some of these terms will be dr r to the power n minus 1 upon r minus 1. Got it? Now I shift this term as here. So finally formula for sum is a upon 1 minus r plus dr is this will I will write 1 minus r to the power n minus 1 upon 1 minus r whole square minus a plus n minus 1 into d into r to the power n upon 1 minus r. This is the sum up to n terms of an AGP. I insist not to remember this formula, even it is very difficult to remember this formula. So it is not required that you remember this formula. So you just see this how I did it. Got it? So this is how we do this. Now do this question. Find P if sum of this AGP is given as 8. Quickly. See, again, same kind of question. I will start with S as 3, 3 plus P by 4, 3 plus 2P upon 4 square, and so on. Now see, this is going up to infinite. Fine. I multiply this series by 1 by 4 and write by pushing a term. So it will come out to be 3 by 4, 3 plus P upon 4 square, and so on. Now you subtract these four terms. 3s by 4 is 3 plus P by 4 plus P by 4 square, P by 4 cube, and so on. So keep the 3 as it is. This is what? This is sum of infinite GP and given to me as 8. So this will be 6. So 6 is equals to 3 plus, say it is A upon 1 minus 1 by 4. Am I correct? So this is equals to 3 equals to P by 4 divided by 3 by 4. Fair enough? So this 4 cancel. So that means P by 3 is equals to 3. So P should be 9. Everybody understood? P is 9. Fair enough? This is the problem, but as such, I contradict with this question. This is also a previous year JEE mains question. Why do I contradict? Because the common ratio of the GP is, no, that's fine. Okay, common ratio is independent of P. Common ratio is 1 by 4, fine. This is totally correct. So your P is 9. Now there comes AM, GM, HM inequality. First of all, for n terms, A1, A2, A3 up to AN. We will call them positive. Their arithmetic mean A is A1 plus A2 plus A3 and so on up to AN upon N. Their geometric mean is A1, A2, A3 up to AN whole raised to the power 1 by N. And their harmonic mean is N upon 1 by A1 plus 1 by A2 and so on 1 by AN. So this is the arithmetic mean, geometric mean and harmonic mean for n terms, and AM is always more than or equal to GM, which is always more than or equal to HM. This equality holds when all the terms means all those terms where AM, GM is being applied. All the terms are equal. Got it? So this is what we call AM, GM, HM inequality. Like first of all, let's do one question. Find the minimum value of A plus B plus C plus D into 1 by A plus 1 by B plus 1 by C plus 1 by D. Find the minimum value of A plus B plus C plus D into 1 by A plus 1 by B plus 1 by C plus 1 upon D. Now see, again if I apply AM-HM inequality, needless to say in the question they are saying A, B, C, D are positive. So if I apply AM-HM inequality, AM is A plus B plus C plus D by 4 is more than equal to their harmonic mean. Harmonic mean is going to be 4 upon 1 by A plus 1 by B plus 1 by C plus 1 by D. Now if I cross multiply, I get A plus B plus C plus D into 1 upon A plus 1 upon B plus 1 upon C plus 1 upon D more than or equals to 16. So minimum value of this product is what? 16. Am I clear? Now, attempt this question. This is a previous year JEE mains question. Like I think it appeared in 2024 or 23 only. Go for it. A, B, C, D are positive real numbers such that A plus B plus C plus D is 11. Find the maximum value of A to the power 4, B to the power 3, C square D. First of all, in any question, whenever you see something like positive real numbers, so that means the thing that should strike to your mind is it can be of AMGN. Am I clear? So if something like this, that positive real numbers you see in a question, that means it can be of AMGN. Now see, they're asking for A to the power 5. I have A plus B plus C plus D as 11. So divide A into 5 parts. A by 5 plus B, A by 5 plus A by 5 plus A by 5 plus A by 5. Divided A into 5 parts. Now we have B cube. So divide B into 3 parts. So B by 3 plus B by 3 plus B by 3. Divide C into 2 parts. So it is C by 2 plus C by 2. And D keep it as it is. These are total of 10 terms. So this all divided by 10 is more than or equal to geometric mean of all of them. That means A by 5 to the power 5, B by 3 raised to the power 3, C by 2 square into 2 into D whole raised to the power 1 by 10. Correct? Now this numerator sum is, this is A plus B plus C plus D, which is given to me as 11. These are total 11 terms, sorry. So this is 11. This power is also 1 by 11 in that case. 5 and 3, 8 and 2, 10 and 1, 11. Yes. So this is 1 more than or equal to A to the power 5 B cube C square D upon 5 to the power 5 3 cube 2 square into 1. So A to the power 5 B cube C square D less than or equals to, this is 5 to the power 5 3 cube 2 square. Now you just manage whatever this. They are saying the maximum value of this. This is the maximum value. And this is given to me as 3750 beta. So beta is what? 5 to the power 5 3 cube 2 square upon 3750. Got it? So with this, you can calculate this value of beta. Fair enough? Now we'll do some miscellaneous kind of series, like the series you see in front of you. This is 1 upon 2, 3, 4 plus 1 upon 3, 4, 5 plus 1 upon 4, 5, 6 and so on up to 1 upon 100, 101 and 102. This is k upon 101. Then 34k is equals to. Got it? Give it a try for a moment or let's start it. Leave it. What will be the rth of this series? rth term of the series will be 1 upon r plus 1, r plus 2, r plus 3. After calculating rth term, whenever you see, always put value of r as 1. So if putting value of r as 1, are you getting the first term? Yes. Put the value of r as 2. Are you getting second term? Yes. Put the value of r as 3. Are you getting third term? 4, 5, 6? Yes. So if you are getting the right first, second and third term, that means the rth term you have written is completely correct. So now it is r plus 1, r plus 2, r plus 3. In the numerator, create the difference of this last minus first. So it is r plus 3 minus r plus 1. Create the difference of the terms last minus first. So what did I do extra in the numerator? 2. So divide by 2 also. So it is half of 1 upon r plus 1 r plus 2 minus 1 upon r plus 2 r plus 3. Am I clear? Now you got this. Now find T1, T2, T3. What is T1? T1 is half of 1 upon 2, 3 minus 1 upon 3, 4. T2 is half of 1 upon 3, 4 minus 1 upon 4, 5. T3 is half of 1 upon 4, 5 minus 1 upon 5, 6 and so on. Now see, I have to do it up to 99th term because this will come while you replace R as 99. So T99 will be half of 1 upon 100 into 101 minus 1 upon 101 into 102. Now when I add all of them, you see they are cancelled. So what are you left with? Sum of 100 terms is, sum of even 99 terms are there. So sum of these 99 terms is half of 1 by 6 minus 1 upon 101 into 102. Got it? Now if you simplify it, you will get your correct answer. They are asking for this, they are saying this is equals to k by 101. So this is k by 101. So if I multiply it by 101, I will get k as 101 upon 12 minus 1 upon 102 into 2. Then further they are asking for 34k. So 34k will be 101 upon 12 minus 1 upon multiply by 34, here also 34, so it is 102 into 2. 34, 3. This will be 6, this will be 17. So it is 101 into 17 minus 1 upon 6. Got it? So now the answer is 1717 minus 1 by 6. That is 1716 upon 6. So 12, 8, 286 is the correct answer. 34k is 286. So this is how we do these kind of questions where method of difference is being used. So the main crux is create the difference of two terms from the denominator in the numerator. That is last minus first. Okay, try this one more question. Sum to 10 terms of the series. Find the sum up to 10. All these questions are from PYQs of JEE Mains. This question came last year only. Find the sum of 10 terms of this series. Now, what will be the nth term? Nth term is going to be n upon 1 plus n square plus n to the power 4. Nth term is going to be this. Now, one more thing that you should know, this denominator is have the factors as n square plus n plus 1 and n square minus n plus 1. It can be easily obtained by adding and subtracting n square. So that first this becomes n square plus 1 whole square minus n square. So this denominator n square plus n to the power 4 plus 1 has factors as n square plus n plus 1 into n square minus n plus 1. Now it can be written as n square plus n plus 1, n square minus n plus 1, and create the difference in the numerator. That is n square plus n plus 1 minus n square minus n plus 1. Now the numerator is 2n. What it basically you multiply the numerator by 2, so divide by 2 also. So it is 1 by 2 times 1 upon n square minus n plus 1 minus 1 upon n square plus n plus 1. Understood? Very easy question. Now do what we used to do. T1 is what? Half of 1 minus 1 by 3. T2 is what? Half of 1 by 3 minus 1 by 7. So this is the pattern of cancellation. So don't do much terms. Directly find T10 is half of 1 upon 91 minus 1 upon 111. So if you add all of them, these will cancel. So sum up to 10 terms is going to be half of 1 minus 1 upon 111. That is 55 upon 111. 55 upon 111. This is going to be the correct answer. Understood? All right. Now try one more question of the same variety. The sum of first 20 terms of the series 5, 11, 19, 29, 41 and so on and so forth. Now see, this series has a pattern. What is the difference of terms here? 6. Then here 8. Then 19 and 29. What is the difference? 10. Then 29 and 41. What is the difference? 12. So basically difference of the terms of this series, they are in AP. Got it? So the series is 5 plus 11 plus 19 plus 29 plus 41 and so on. Let the n minus 1 term is there and then n term is there. Got it? Now write this same series once again by pushing one term. So it is 5 plus 11 plus 19 plus 29. Then Tn minus 1 will come here and Tn will come here. Agreed? Now subtract both of these terms. Minus, 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 minus. Both of the series. So this is cancelled here. It comes 0. It will be 5 plus. Now see. Differences are occurring from this. So 6 plus 8 plus 10 plus 12 up to. Difference are occurring up to this term. And separately you have minus t. So up to this point, from there till here, there are total n terms. Now 5 you separated out. So from this to this is an AP of n minus 1 terms. AP of n minus 1 terms. Yes or no? So bring this T1 to the left side, Tn. So your Tn is 5 plus this AP. So that is 5 plus AP sum will be n minus 1 by 2, 2, 8, 12 plus n minus 1. So it will be n minus 2 in this case into D. D is 2. So it is 5 plus n minus 1 by 2. This will be 2n plus 8. So it is 5 plus n minus 1 into n plus 4. Correct? This is your Tn. So it is n square plus 3n plus 1. Once you get this nth term, do not just settle down. Put the value of n as 1. Are you getting the first term of the series? Yes. Put the value of n as 2. So 4 and 1, 5 and 6, 11. Second term, yes. Value of n as 3. 9 plus 9, 18 and 1, 19. Yes. So if 3 terms are fine, that means your series is fine. So this is your Tn. They are asking for some up to 20 terms. So before that, find Sn. Sn is what? Sigma n square plus 3n plus 1. Now we have the formula for all of them. That is n plus 1, 2n plus 1 upon 6 plus thrice of n into n plus 1 upon 2 plus n. Am I clear? And now in this entire expression, put n as 20. So it is 20 into 21 into 41 upon 6 plus 3 times 20 into 21 upon 2 plus 20. Got it? Now you simplify it, you will get one of the answers, which is a 4-digit in the options. All right. Okay, anyways, that would be all for today. We have done almost every type and variety I tried to cover in sequence and progression. Binomial we could not do because the time constraint we have. So, but make sure you practice more and more. This is a prominent, important chapter. So 1 or 2 questions you will definitely expect from this. And more importantly, this sequence and progression chapter is like it is being used everywhere. Along with its own questions, it has been merged with other chapters and made much more beautiful questions. All right. So one voice, thank you so much. Start your preparation and all the best. Thank you.